Milan, what are we going to talk about today?
Now we'll talk about Tesla switch and similar devices.
Can you tell me, does that have anything to do with the scientist Nikola Tesla?
Actually, nothing. Like Tesla car has nothing to do with Tesla. It is classic to take attention of your device and to take attention. I am not against that because it's quite normal to use like this. But maybe there is a Tesla symposium. I don't know is it still there in America, in US, and one guy presented that, or there maybe because of that symposium, he needed to present something related to Tesla, and he gave the name. It doesn't matter, but Tesla had one patent for a high frequency Tesla coil, where he used parallel and serial connection of capacitor to discharge very sharp this connection. And but again, it's even Tesla didn't invent and changing parallel to serial connection. He used that for that application, but he didn't invent this, so it's not connected to Tesla. But today, when I was thinking about this video, it came to my mind a friend of mine, Stevan Buacha, and I dedicate this video to him. He's 15 years older than me, and he's not in good shape now. He's not feeling well, but why he came to me a long time ago, he exactly told me about this device, similar devices that he, with his friend, what they did during 60s. And after that, when I started my journey in this territory, he always was like to hear what I'm doing, then we exchange ideas, and I wish to him the best, and I hope he will recover. So the root of Tesla switch is also something very common, and nobody knows who came first to that idea. Idea was something like this. They so take two capacitors uh, and put them parallel. Parallel means plus to plus, minus to minus, and then you increase the capacitance, double capacitance if they are the same. So charge them from the source. In this case, let's say from the battery, charge two capacitor parallel, and but through the load, and capacitor will get 12 volts. Then put them in serial connection to get 24 volts. I now I just give visualization. You don't have to do like this. So put them in parallel, then you will have 24 volts, and then you can discharge them back to the battery through the same load. And when they equalize, then there will be 6 volts in each. Then you put back parallel again, then you need to add 6 volts in each, then take back. So something like this. And what is wrong with this idea? Okay, in that time, maybe 70s, it's old. You can't say someone that guy invented this. It maybe is this principle is over 100 years old, even more. So, what is the problem? If you calculate, so many people make. I will rather say beginners, but is nothing wrong if someone beginner. Uh, let's say when we do not use some part of our, let's say, of physics, if we are related with physics or with mechanics, and if we do not use something often in our work, then we forget many things. I made mistake something in mechanics very week ago when I calculate by logic something and I make completely mess. So it's quite normal. So where they making mistake, they calculate the energy stored in capacitor, and if you have, let's say let's say that they are 1 farads each. Parallel, when they are 12 volts, then they had stored energy 144 joules. So it's the same if you are put in series, then it's 24 volts, but it is half, 1 farad total capacitance. Again, we have the same. So, which means if they calculate just what happens inside of capacitors, so they get wrong conclusion that energy is the same all the time, and what your load produce is gain. It's problem because it's a wrong way to calculate. What is the important here? Important is amount of charge column. So and battery. So when you put that in calculation, then you will see that the source will losing energy with each cycle. I mean, when it's sent. I said several times in my videos that for capacitor, for batteries, for the electrolyzer, it's not important joules. It's important how much charge you take out, how much charge you put in. So when I was shocked that someone says, "Oh, from how many joules I sent from my device to battery," and then calculate how much gain he produced. And but this guy was with experience, so called. So it's completely wrong. That's why it is very common mistake when you're doing something like this. So then someone can had different idea to go forward. There is a patent, Carlos Benitez, I think Benitez from 1915 something. Then when he used on the beginning 4 batteries, and let's say like this, those two are in series, so they have 24 volts, and those they are in parallel, so it's 12 volts. So difference is 12 volts. So when we connect like this, they will discharge, they will receive charge, and when you finish, then you can reconnect this uh, to be in series and then to be in parallel. So it is what people call Tesla switch. What is working with batteries and capacitor is not the same thing with many direction, but major difference here. Let's say this this battery 7 ampere hours. When you put them parallel, you make double. So they are 14. But over here they are 24 volts, but total ampere hours remains the same like one of them, which means 7 ampere hours. But for capacitor is completely different. When they are parallel, let's say this they are 10,000 microfarads. So each when they are parallel, they are 20,000 microfarads. When they are in series, then they are 5,000 microfarads. Four times less capacitance in when they are in series, but with battery they are half capacitance than in parallel. So it is very important for this device. And later Benitez turns to capacitors, and but I'm not saying that I'm not sure. I'm sure that someone else before that's not he the first guy. So what is the problem with this system? This system, what happens? We have 24, two in series, two parallel. Let's say that current is 1 amp. So this one is give 1 amp, and this one also give 1 amp. But over here, each of them will get half. So from the beginning, this we cannot fully charge. We cannot finish. I mean, if they are close with voltage, but it is of we are losing game game from the beginning. And when you reconnect, you just then so this when in series, they each one will give one, they will get half, and it's not productive, and it will stop. And if you think that you got more energy, you no, even worse. You can use back converter for 24 to charge those two uh, double, almost without losses. But then you will not have space for load. So then what is the point? Just to charge, discharge, and no work. So that's why this system is very efficient, not efficient at all. You can get a little better if you do like this. Let's say there are 4 batteries and there are 3 all in series. So um, each battery over here is 6 volts. So which means this one gives 18 volts, and this one that one's gives the 24 volts. 6 volt is different. So I have two LEDs, two group of LEDs in series, and then I'm to connect, then I'm discharging. And so why is better than here? Because over here, let's say we have 24, this is 5 ampere hours each. So we have 24 volts, 5 ampere hours, charging 18 volts, 5 ampere hours. So it's talking about capacitance, it's go 1 to 1. Then I will just use prepare. Then we need to reconnect 24 to 2 times 12 so they are in series. So in that case 18 volts will so imagine that this one this that those four will reconnect like this, and then from 18 goes to 12, and in that case is ratio is 1.33, which is better than this one, but anyway it is not the way to go, because you will losing energy all the time. You then you will activate so many input e-action, so many batteries for. So see how many batteries, let's say over here 7 batteries I need to put in action for a voltage of single one completely, and uh, um, no gain. If someone tells you that there is a gain, ask measurement and proper measurement. Not that someone, let's say, will charge with one battery 4 batteries for 30 minutes, then 4 batteries he will discharge for 5 minutes, and then again he will charge for 30 minutes. What I said in last video, it didn't discharge the batteries. It is fake. So don't look instant measurements batteries on the load on the run. It must be measured properly, like I described in last video. It was the first, let's say, version of that. There is a nice quote of Stevan Buacha, which I said a long time ago. I spoke about him, about homopolar generator Bruce De Palma Itevari from India, and he told me, Milan, when inventor is obsessed with his invention, don't listen him. And they are not capable to see bad side of invention. And I said, okay, but they are PhD professors. And he told me, then it's even worse. So I will use that part. It came to me. So people, I'm not saying that to nobody now. Don't try that. I will actually say, try. Why not? Like last time, I like to play with things, but I need to be real what I'm doing, especially if I need to finance these things. And people needed to change approach because this principle is not working. No gain. And then there was modification of that to actually this one, modification on this one, where they change. So there is electronic which change all the time, parallel, serial, parallel, serial, and it's before that people used to drive, let's say 1 hour all to the end, and then reconnect, and then slowly then Tom Burden. I'm not sure does Tom Burden came first with theory or he tried to explain after math that there is a chance that surface charge on the lead electrodes beside the ions, negative energy, negative time, whatever. And so uh, they try to, by pulse, short, each pulse, they the frequency, it could be from 7 to hertz to 200 hertz, depends of you, but each pulse will change connections. And what everybody will say, and I agree, it's not good for battery at all. For this type of battery, it's not good at all. It kills the battery. There is another problem. I will zoom if you can see it. Tell me when it's okay to talk.
Yep.
Okay, this is from Ronald Brand. So it is that switching. He asked for electronic switching, but he came with this concept. So when they are in series, they are activated this switch, and that one, and then they are parallel. So let's say this one is activate, those two activate. So they are in series, and they are go to parallel charge via load here and reverse. So over here we see it's like this. Then they change. Okay, it is old-fashioned from that time, electronic by transformers for switching transistors, and it is, do not go in details, do not be confused, and it is actually what is described in here. So it's diode go here and finish here, but it's parallel, it's different. It's this branch closing back is parallel with this AC load. It should be LEDs here, because it makes no sense to be a diode, because it's already diode. Why? Because its second one shows that it's diode. And if it is diode, so it's not high power here. It is milliamps. And someone they changed later diode, put in the opposite direction, in non-conductive direction. So, and it lights, and they are saying that inspired by Tom Burden, that it is negative. Because I work with LEDs, where I'm in business with LED lamps, street lamps, solar. Okay, I will get one LED. Sorry. So, is this okay? Can you see? So the shorted leg is always minus, and it's conductive from here in that direction, from anode to cathode. And when you read, they're working about 3.5 volts, and they are 0.06 watts maximum. When you turn opposite and you go with higher voltage to cathode, you will see that it's okay. Doesn't not this diode. Tell me when it's okay. This diode is opposite direction, and because it passes in non-conductive direction, perhaps they believe that's why it's negative energy, but it's not negative. It's even it's 5 volts. When it's serious, it is 10 volts. When you have switching, no matter that if you have coil or not, there will be back EMF. There will be peaks about 100 volts easy, even with short wires, and it's measurable. So that means that high peaks will pass through LEDs, and they will emit dim light and will vibrate by vibration, will dim the light. But if you continue forward, then they will produce proper light and will blinking on proper light. When it happens, LED is killed on a little strange way. When you measure resistance, on each direction, it will be about 11 ohms, 11 to 12 ohms. But and it will draw on 3 volts, it will draw about 0.25 amps, but not with emit the light if you connect to DC source. But when you pulsating, it will emit light. So if you see that it's blinking, you think that the LED, but LED is not working, is actually more resistor than LED, that it's have direction. It goes in both direction. Why I said many times when I read paper from Tom Burden, there was many that I like it. But what's the problem? Tony Burden was talky. He talked too much, but I never saw that anything what he said that someone made over unity like he claimed. He was easy to talk. Like this, he was fascinated. He was a good scientist, but there is no results. There is no results. It's not critic, but it's no results. If you ask me, do I have a result? I also have no results. I have some results, but I'm not satisfied. So basically, it's going with that.
I guess till next time.
Thank you.